Hey everyone, welcome back. In this video, we're going to look at more examples of cash flow problems. So, here in question 1, we have a cash flow diagram that's been given to us, and the interest rate is 15%. So, we have three annuities, three uniform payments of $100 and a payment of $500 at year 6. Okay. And we want to find the value of P being a negative payment, a deposit that will be equivalent to all these positive cash flows or these amount that is being withdrawn. So if I were to solve this analytically, I can immediately see three annuities and I can convert these annuity payments into a present value. So let me just write that down. So you have a present value given annuity. First, the amount of each annuity is $100, and you want to convert it to a present value from an annuity at an interest rate of 15%. And we have three payments, so n will be equal to 3. And now we're left with this $500 payments, which is at year 6, and we want to move it back to year 0. So that is going to be since we're moving back in time, that will be a present value given future value. Again, the interest rate is 15%. And here the value of n is going to be the number of years you're moving back. So in this case, we're moving a total of 1, 2, 3, 4, 6 years back. Okay, now from here on, you just have to look up the correct formula for conversion from annuity to the present value and just plug in these numbers along with the annuity amount. Same is the case with the other expression where you just have to where it's just a simple case of plug and chug. Now the way I'm gonna solve this problem and the next problem is gonna be using by laying it out in Excel, and that way it makes it much faster for me and I don't have to care about the structure of the cash flows. Okay, we're in. So alright, so my year goes from year 0, year 1, and the problem is going from, yeah, I think 6 years should be enough. So we'll just track this down to 6 years. Okay, and we have our cash flows. At year 0, we're making a negative payment, and we're looking for that value. So I'm just gonna put an initial guess for that. Let's say 1000. And at year 0, that's a negative payment, hence a negative cash flow at year 0. At year 1, we have $100, 100, 100, nothing at year 4, nothing at year 5, and 500 at year 6. Okay. And my interest rate was 15%. So that will allow me to get my discount factor each year. Discount factor. And that's just going to be 1 plus the interest rate raised to power the negative exponent of the respective year. Okay. Alright. Looks good. At year 0, the discount factor is going to be 1, and as we go from year 0 to subsequent years, the discount factor should start decreasing. And finally, our discounted cash flows. So each cash flow multiplied by the discount factor, and we just drag it down. Alright, looks good. Now the NPW, I'll just write it down here. the net present value is going to be the sum of all the discounted cash flows. All right, so this is the discounted cash flow array that I've selected here. All right, now in order for this in order for the p-value at year 0 to be equivalent to all these cash flows, the net present worth, the sum of all these discounted cash flows must be equal to 0. So let's do that. I have my solver here. My objective function is going to be npw. That's correct. I want to get that to a value of 0 by varying p, the variable I'm solving for. All right. Okay, so if I just run this once more, I should get a more finer solution. So $444 to the to the nearest dollar is the amount, is our answer for P. All right, very good. So here I have another problem. In this problem, I'm given the cash flow at year 0, a positive cash flow of $1,000. And from year 1 to year 4, there are annual annuity payments, a uniform series of payments, and A is my unknown in this problem. And at year 5, year 6, and year 7, I have a sort of a gradient payment that starts at 500 and ends at 700. So I want to find the value of A that balances this cash flow. Now, if I do this analytically, it will be a bunch, like I'll have to do a bunch of different conversions. Like, sure, I can take this present value and convert it to annuities, but these gradient values, they're not really set up in a nice way for me to deal with them analytically. So if I were to resort to this method that I use here, it should be much easier for us. So I'm just gonna copy the structure, and obviously my cash flows are gonna be, I'll have to reinitialize them. My discount factor should remain the same. Oh wait, yeah. Okay, my discount factor will remain the same. So let's see. We're looking at the second problem. At year 0, you have come on, okay. Year 0, a positive cash flow of 1,000. Good. So A is the unknown that I'm solving for here. Let's give it an initial guess of 100 equals A, and I'll make it an absolute reference since this is gonna go from year 1 to year 4. Bravo. So at year 5, the cash flow is negative 500, negative 600, and at year 7, I'll have negative 700. That's correct. Just making sure all the formulas are correctly implemented. I have my cash flows, and I have my discount factors, my discounted cash flows. So in this problem, I'll set up a new objective function for the net present worth by taking the sum of this new array, sum of my discounted cash flows. And in order to balance these cash flows, remember, I have to get a net present worth of 0. So the positive cash flows at different times balance out the negative cash flows at different time periods. So yes, I have my new objective function. I'm gonna have a different decision variable this time. All right, value of 0. Let's give me 1 second. I think we forgot. Yeah, we did not select the new objective function. All right. Okay, let's see. There might be a problem with the structure of these cash flows. Hmm. Okay. Now it is possible that maybe, hold on. So I don't want to make these non-negative. So let's see what happens. Okay. So the value of A that we've gotten is actually negative $80.2. So that means that the actual solution to this problem, in order to balance out the cash flows, will need negative annuities. So at year zero, you have the 1000 payment, so 80.26, I believe. Yes, 80.2. 80.2 from year one, year two, year three, year four. So you'll have 80.2 as a negative payment, and at year five, you'll have a 500 amount, 600, and 700. And that's how these cash flows, this particular cash flow problem is balanced out. And as you can see, it was much easier and much more much better laid out than you plugging and chugging any formulas. And once again, the only principle that we've been using so far is that the net present worth of all these cash flows, the value must be balanced out to get your to figure out the annuities in this case, or the present value in this case. All right, I hope this was helpful, and hopefully by implementing this method, you should be able to solve any cash flow problem that has been laid out for you. Just remember, guys, that you have to balance the positive cash flows with the negative cash flows. All right, see you guys next time.